All right. Cool. Well, thank you for letting me become part of Toronto's DevOps Days again. I was back here a couple years ago talking about chat ops. This time I thought I would kind of bring something different to the table. Let's talk about metrics and some things that are important to understand that I think sometimes is often overlooked. So beyond the mean time to recover is what we're going to talk about today. For those of you who've not met me before, my name is Jason Hand. I work at VictorOps. You've already heard all about us, so I'm not going to go into detail about that. How many of you have ever read this book here, the Site Reliability Engineering book? It came out last year. It's pretty good. It's actually really, really good. It's specific to Google, but there's a lot of stuff in there that is really sort of, I think, surfaced the conversation about reliability, availability, just a lot of the things that DevOps is, has been trying to teach us for a long time. So a lot of times, I think the SRE and the DevOps conversations kind of blend a little bit. But this is a really good book. And I love this quote right here because it says, I'll just read it to you. The most relevant metric in evaluating the effectiveness of emergency response is how quickly the response team can bring the system back to health. That is MTTR. So clearly, there's this sort of focus on high availability and reliability. And a lot of that has to do with our SLAs. Many of us are probably very familiar to things like 5 nines. We're trying to get to the point where it's just complete availability. And when you have this sort of situation, when you're trying to focus on availability, you end up going into this more of a defensive stance. You really try to protect your systems and prevent bad stuff from happening. You want to defend every one of those nines and make sure that nothing happens and our system doesn't go down. And so you get into this mindset of, well, we're going to predict what's going to happen, and then we're going to try to prevent that thing from happening. Well, that's very challenging. But when you do have this mindset, typically the metric that you kind of most first look for is what's the time between our failures. If we don't want failures, if we don't want downtime, we want high availability, shouldn't we be trying to maximize the time in between the failures? So there's a lot of people that really do focus on the mean time between failures. The problem with this line of thinking is that we're operating in complex systems. And in complex, nonlinear systems, there's always going to be problems. It's just sort of the nature of working in the systems that we're in. This type of stuff just happens all the time. Working at VictorOps, I can tell you this, but also as just a long-term sysadmin, most of my life and most of these gray hairs are because of trying to defend those nines. Bridget earlier mentioned John Allspaw. John's a big part of this community and talks a lot about this type of stuff, especially postmortems, and came up with the idea, or at least the term of blameless postmortems. And I'm going to read this one to you as well. Failure cares not about the architecture designs you slave over, the code you write and review, or the alerts and metrics you meticulously pore through. Failure happens. This is a foregone conclusion when working with complex systems. And what John's getting at here is that we're just not going to get away. You can't engineer failure out of your systems. And while mean time between failure is something that we want to pay attention to, there's actually other things that we want to look at. And mean time to recover is the one thing that he sort of has pointed out. And a lot of other people in the industry have done that as well. This is from his blog. It's called kitchensoap.com. And I'll just read 2 more things on here. Being able to recover quickly from failure is more important than having failure less often. And then down at the bottom, I've got highlighted there, since failure will happen. And then he's quoted a person here, I forget his first name, but his name's something Hammond. But he says, if you think you can prevent failure, then you're not developing the ability or your skill set to actually respond to failure. And I think that's kind of the part that a lot of people overlook. They start to want to defend their systems and prevent these things from happening, but they don't actually work on the team response and being able to recover from problems really quickly. This is another great book. In fact, a lot of this presentation is just going to be kind of showing you the stuff I've been reading lately. But Effective DevOps from Jennifer Davis and Catherine Daniels, a fantastic book. I definitely recommend you reading it. They talk more about the availability as well, and they use the metric of mean time between failure over mean time between failure plus the mean time to recover. And this is the most commonly used measurement on how often a system or service is available. So clearly, we still think that mean time between failure is important. But if you sort of start looking at all this in a little bit more holistic way, you'll realize that what we're really starting to realize is that it's more about that response and recovering very quickly than it is about trying to defend our systems, trying to monitor them. Monitoring, of course, is super, super important, but not necessarily with the idea that we're going to protect or prevent things from happening. Another awesome book that came out last year, the DevOps Handbook. How many have read this? This is kind of like the next installment of the Phoenix Project, written by Gene Kim, Jez Humble, and Patrick Dubois, and John Willis. I highly recommend it. It's just a lot of case studies and a lot of different interesting things about pretty much everything in the spectrum of DevOps. And for sure, you'll see some stuff about the mean time to recover in there. The State of DevOps report comes out every year. Puppet and Dora puts this together. It is full of all kinds of stuff. But this year was really awesome, because one of the things it always talks about is high-performing organizations and low-performing organizations. And they point out that the high-performing organizations, they're able to respond and recover 168 times faster than the low-performing organizations. 168 times faster is extremely fast. And so I think it's really important to recognize that as an important metric, that you need to be able to get yourself in this position where you can respond and recover very quickly, because that's going to set you up for all of the other things that we kind of look for within the DevOps conversation. And if you look around the web, you go to DevOps.com, you'll see Gene talking about it. We talk about it, of course, mean time to recover. In fact, we've been writing about it for several years. It seems pretty clear that mean time to recover is that magic metric. It's that one thing you should drive down to really increase your serviceability, your reliability, all that kind of stuff. So I'm going to pause real quick here, and I want to ask a question. How many of you have been asked this before at some point? What is the ROI to DevOps? I get this question, I don't know, maybe once a quarter or something, usually somebody that's kind of new to the DevOps, and immediately this is kind of my face. Are you serious? Like, you're trying to find the ROI of DevOps. But we're in business. We're in the business of providing things and making money. And of course, ROI is going to be important to somebody, probably above us. How about this question? How many have ever had this? What did that outage cost us? Usually when I see that question, I'm like, that outage cost me about a year of my life and a couple more gray hairs. That's all I know. That's my cost of outage. This this year, the State of DevOps report did us a favor, and it came up with a few things that are actually really important, really relevant for those types of questions. And also, I think this is something else that gets overlooked within the State of DevOps report. So if you haven't looked at it, definitely go back. But let's talk about a few things in here. One of the things I noticed, of course, jumped right out to me, is understanding the ROI of DevOps. This is kind of early on in the report. And of course, as soon as I saw this, I flipped ahead real quick and see what are they talking about. And I finally found it. And what they're talking about here about the ROI is really more about the expected savings. And a lot of that has to do with the downtime. If you see down there in the box, it includes the cost of downtime and the cost of excessive work. So this got me thinking, all right, that's interesting. That helps me with my conversation starters and when people do start to ask me about the ROI. So I flipped ahead a little bit more, and I found, hey, they've actually come up with a formula for the cost of downtime. Now we're talking, now we're getting something that's a little bit more interesting. This is something management is going to want to know. This is going to be something the CEOs and just people the higher ups are going to ask if you're going to propose using some of the principles and some of the tools and some of the stuff that we talk about at DevOps Days. They're going to want to know, what is this going to do for us? Well, when I saw this formula, it got the gears turning. And so I decided, well, let's break this down a little bit and let's do a talk about it. Let's talk about all the things that we need to know to understand the cost of downtime, and then also the ROI of downtime. So let's take a little bit closer look at every one of those. The cost of downtime, according to the State of DevOps, is the deployment frequency times your change failure rate times your mean time to recover, which apparently is very important, and then the hourly cost of an outage. And I'll admit, the hourly cost of an outage is very, very hard to figure out. And it depends on your company, depends on your situation. It includes understanding salaries and all kinds of different stuff that come up whenever there's a problem, whenever there's an outage. So I'm going to go into each one of these real briefly. So let's start with deployment frequency. According to the State of DevOps report, deployment frequency is how many times per year your own organization deploys change. And they sort of register a high performer as doing about 1,460 per year, whereas a low performer is about 7 per year. How many of you would think you're closer to the high performers. Okay, and then closer to the lower performers? That's fine. And we all kind of fall in different places on that spectrum, and we're trying to get better and trying to get faster. But that's the deployment frequency. And then there's the change failure rate. So when you deploy, how many of those changes are actually causing problems? The percentage of changes that cause an outage in an organization. High performers, there'll be some sort of problem about 0 to 15% of the time. And then the low performers, it's more like 16 to 30% of the time. So how often is there a problem whenever you make these changes with your system? And then the mean time to recover and the hourly cost of outage. I already said the hourly cost of outage is really, really difficult. But they do have an example in the book where they use a company who's determined that their cost per hour is about $500,000, which I know that's a little high if you're kind of a smaller company. But for the enterprise, that might be a real number. And they've got some example here for the high performers. They're saying that for a high performer that has about an outage cost of about $500,000 per hour, that's going to cost them, that downtime is going to cost them about $37,500. Now, if you're more of a low performer and that's your cost of an outage, that could be upwards of almost $3 million. Now, I will say it's a little hard to see here, but they point out that the low performers are probably not going to recover in an hour. They've given them more like 24 hours, which is pretty common for a lot of problems in larger companies. But what about MTTR? What is the mean time to recover exactly? Well, according to the report, it's how long does it generally take to restore when a service or incident occurs. And an incident, by the way, is something that's sort of unplanned, an unplanned outage, service impairment, that kind of thing. But what does mean? Well, first of all, what we're really talking about here is the arithmetic mean. And that's, for most of us, that's just what we know as an average. So what we're taking here is the average time that it takes to recover. But the problem with this is averages don't really give us a good picture. They don't tell us, first of all, the specifics of those incidents, what's really going on with each individual problem. There's a lot of different ways problems can occur. And then there's limitations that come with those averages. They don't really account for the outliers. If there's something really, really bad, that's going to maybe screw up your average. If there's something that's really, really good, that's going to screw up your average. So it doesn't really give you the full picture of what's going on. In fact, it starts to distort the picture a little bit. Earlier this year, I read a book called The Making of Behavioral Economics, Misbehaving the Making of Behavioral Economics. Really, really good. If you ever read Thinking Fast and Slow from Daniel Kahneman, I think you'd really, really like this book. And actually, this is kind of where I got some of these ideas. Richard Thaler, the author of this, he started pointing out the flaws in using averages as metrics. And it got me thinking, wow, we're kind of all screwed if we are just going to rely on MTTR all of the time. Here's an example. This is actually a customer of VictorOps. And this shows basically that they have 40 hours for their mean time to recover. 40 hours. Now, I can tell you it doesn't usually take them 40 hours to recover, but what has happened is that they've had a couple of really, really bad problems come up. Usually, you can see on the left there, they recover pretty quickly. It doesn't take them that long to know what's going on. They get the team assembled, they go through their run books, they triage, they do everything they need to, and they recover. But there has been a few things that has really been bad, and it has shifted their entire average, which really, really impacts your ability to determine what your actual cost of downtime is. So this leads me to think, well, what are we doing talking about the mean time to recover if we're just talking about averages? This seems total bull. Furthermore, what's actually happening when you see those types of things skewed? If you're think about the scenario where your actually mean time to recover is about 60 seconds. What's going on there? Probably there's something auto-resolving itself. Or maybe there's somebody there just clicking a button. Resolve, 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 resolve. Why would you do that? I don't know. Stuff like this never really happens. AWS has never gone down. We've never said, I know, I know, I know. So when you see these really, really bad outages, you get a Sev 1, Sev 2, that can really throw off your numbers. I'm sure all of us has had some sort of outage, but luckily not everybody's had a bad one. But when you do, it really is upsetting in a lot of ways, and it's going to screw up your averages on the time to recover. Well, if that's the case, what else should we be measuring then? Maybe you've drank that Kool-Aid, you're like, okay, I get this, I know math. Well, if you know math, you probably understand median is your next best place. Median's gonna sort of take us right to the middle. Let's take care of those outliers and just cut them off. What's the median time to recover? How about the volume of alerts? Are you getting a lot of SEV1? Are you getting a lot of SEV5? It's important to understand sort of the breakup and sort of the demographics of the different types of alerts that you're having. The total number of outages. This is important, especially if you've got SLAs that determine, it's not necessarily just about downtime, but they want to know that you're only sort of allowed to have so many outages in a certain period of time. Maybe you've got some flappy services. There's something out there just making noise just because it feels like making noise. You want to go out and understand that type of stuff. Actionability, this is the big one that I think really people don't take enough time to understand. If you're getting paged in the middle of the night and you can't do anything about it, that's not good. You want to be able to make sure that any alerts, anything that has to do with your incident management, that you're actually paging people that can do something and that they need to do something. Because it's actually pretty inhumane to do sort of otherwise. Also, it's important to understand the alert types. We want to be paged on critical. We want to know when something is really wrong and somebody needs to do something about it. But if it's an info or if it's a warning, maybe we don't get paged. In fact, you shouldn't get paged. But we want to know about that. And it's important to sort of keep track on how many are critical and how many are just sort of warnings. And then alert volume. Alert volume per day. This one's actually really, really helpful. But you have to be careful, again, because it's an average. So be careful with how you calculate that. Alert times. This is another one I think a lot of people overlook. Are we getting paged on my own time? Maybe I like to go out and hang out with my clan and LARP, but maybe I want to go do something else. Maybe I have a family, and if I'm getting paged all of the time after hours, that's a problem. And it's something that a lot of companies don't really pay much attention to. And then, of course, the mean time to acknowledge. That's another important metric, but it has the same flaws. We're talking about another mean. Now, when you start to look at the incident life cycle, the whole incident, not just like what happened until you resolve, but like the entire thing. We've actually got 5 different things that happen. First, you detect it, okay? You've got some monitoring in place. It's going to tell you, hey, something's broke, or something looks like it's about to break. And then you get into the response phase. And response phase is when teams come together and they start to triage. And like, okay, I need to get this person. I need to let this team know what's going on. And we're going to dig in. We're going to identify it, investigate. That's part of the response phase. And then you actually get into the fixing phase where you're in remediation. Teams have started to understand what the problem is. They're running little scripts. They're asking their bots to do things for them. They're actually making the service come back, or whatever the case is. And then after we've resolved the incident, of course, everybody needs to do a post-mortem. We go in, we need to do it probably within 24 hours, but definitely no longer than about 72 hours. And we want to talk about what happened. We want to talk about it in great detail, because there's a lot of stuff that happens during an incident that can uncover ways to improve. And at the end of the day, that's sort of the main takeaway from DevOps, is that we need to constantly improve, continuously improve the things that we're working on. So we get into this analysis phase where we're doing postmortems and we're talking about what happened and we're digging in and we're trying to figure out details of where we can make improvements. And then that leads us into the readiness. We take all the information that we've gathered from that postmortem. What are we going to do? We're going to create a JIRA ticket. We're going to create some sort of action item. We're going to give that to Jason. We're going to prioritize that above all other work. Features aren't important right now. We got to fix this system because features aren't going to work very well on a broken infrastructure. And then we're back to detection, and we're just constantly going in this loop where we're just improving all the time. And so if you look in those first 3 phases, where you're detecting, responding, and then remediating the problem, you can actually, if you break it down at a very granular level, and this can happen in a post-mortem, you can understand what took place in the response phase, what took place in the detection phase, what took place in the remediation phase, and how can we make that time that it took us to even know about a problem or find the right people, and then actually recover from it. How can we improve that? Looking at those metrics is also very important, because you can start to actually see the great, great detail of what took place during the outage. Biometric data. I think this is really fun, really interesting. Sometimes, at VictorOps, we'll have something go wrong in a different environment, or even in production. Some some things happen every once in a while. And it's funny, a lot of us have the Apple Watch or some sort of wearable, and we all like to go see what our heart rate does when the alarms go on. And usually it's about 120 beats per minute, which is, I guess, expected, but your heart rate goes up. That does impact you if you're doing that a lot. When you're constantly under stress, constantly under duress, there's a lot of things that you want to sort of pay attention to. And I recognize, there aren't systems out there right now that are providing this to you, but it is kind of an interesting thing to do. In fact, companies have been doing this for a little while. There's famously, Etsy did this like 3 or 4 years ago. They released their mean time to sleep. And if you go to that link there, you'll see this talk that was given at Velocity, I want to say about maybe 4 years ago, where they talk about how they give everybody on their team Fitbits to wear. And then those Fitbits would track their sleeping patterns while they were on call. And they would see that they're actually taxing their on-call engineers, the people that are responding, way too much. And that's something, that's kind of something that we wouldn't think about. It seems like ops are just supposed to, respond to outages. It's just part of the job. But you also have to realize that we're humans, and there's only so much we can do. And we have to keep an eye out, especially for burnout. So we have to kind of make sure that we're keeping tabs on a lot of different things. So I know kind of went through those a little bit quickly. But what I'd like to ask of you is, this is sort of your challenge, is that go back to your teams, go back to your companies, and start examining what's going on. Are you even tracking the mean time to recover? If not, how do you start doing that? And then beyond that, what are some other metrics that we should be doing? Because really, MTTR is clearly important. It can help us determine the cost of an outage and the cost of downtime. But there's more to the story. There's a bigger picture that we need to pay attention to. So we want to discuss some of the additional metrics. How many of you are actually tracking your deployment frequency? Yeah, not many hands. It's something that we can very easily do. We should know how many times we're deploying into production. How about change failure rate? Anybody tracking that? A couple hands? Again, that one's pretty easy. It's pretty obvious to know, hey, we pushed to production. There was a problem immediately. That's not a hard metric to track, and it's a very important metric to track. And then a mean time to recover, of course, we have ways to measure that. And then the hourly cost of outage. This one's going to be the hardest one. This one's going to require getting management involved. There's probably spreadsheets. It's going to get tough. But if you can get all that stuff, you do start to have a pretty good picture of a lot more of what's going on whenever you're dealing with infrastructure problems or software problems or just service problems. This is another one, too, that I think is often overlooked. Anything that can be measured can be gamed. We know that. If you ask me to make sure that I respond or do a thing, doesn't matter what that thing, by a certain time, I'll make sure it gets done. I know how to use chatbots. I can make sure that all of my incidents get acknowledged or get resolved or whatever by a certain time. So that's something you have to keep in mind. Once you put those incentive structures in place, people will do whatever it takes to hit that and not care about the results that come from that. Incentives is really why we're here at all. DevOps has taught us, but taught us that when you have competing incentive structures, when you've got your developers who are pushing really hard to get features out, and then you've got the operations teams who are pushing really hard to just maintain those infinite nines, that's going to butt heads. And that's why we're all in this room. That's how agile infrastructure and the things that Bridget was talking about with Andrew and Patrick this morning, that's sort of how we got here, is we decided that we need to shift some things around. We got to work together. We got to make sure that our incentives are aligning to the business and to the customer. Because if some people are trying to push features out and others are trying to protect the services and protect the uptime, there's going to be friction. There's going to be friction in the system. And so this is sort of my cautionary tale of just be careful about incentive structures when you put them in place, especially when trying to reduce the MTTR, because people can automate that. And then this is going to let you understand how much money you're throwing out the window every single time the pager goes off. Because there are people who really just either don't care or don't know, and companies can be hemorrhaging money because there's a problem. And by doing that, you'll be able to answer this question that everybody's got on their mind is what are we going to get out of adopting these DevOps principles? What is the true return of investment for DevOps? So So I got a couple final thoughts here, a few more minutes left. Jerry, he's the best one to give us our final thoughts. Everybody knows that. Mean time to recover is super important, okay? I don't want anybody to say that the takeaway of Jason's talk today is that mean time to recover is total bullshit. Sorry. It's important, but there's more to the picture. Identify what's the noisiest alerts out there. If you've got really noisy infrastructure, people are going to have alert fatigue. They're not going to respond as quickly. There's just a lot of things that they start to ignore. Oh, that thing happens all the time. I'm not going to worry about it. Bring more people into the fold. This is a controversial tale. I saw earlier about half the room is developers. How many of you are on call? Not bad, not bad. I don't know what your conversations were like when you had this, but the ones I've seen do not always go over very well. Put the developers on call. Actually, okay. Maybe I should say it this way. Show them that it's fine to be on call. It's not that bad. Don't go around telling people you have to be on call. Another one, too, we talk about in DevOps constantly. Let's shift things to the left. And it took me a while to even understand what the heck people meant by that. But all we're talking about is let's take all the stuff that we usually just bolt on in production, monitoring and alerting usually, let's move that further left. Let's put that into the development lifecycle so that the engineers, they know how to use New Relic and Datadog and all the awesome tools out there. And they know how to use PagerDuty and VictorOps and OpsGenie. They know how to use these tools so that by the time it gets into production, being on call is just part of the job. And also, because they don't want to be paged in the middle of the night, they probably improve the quality of their code. So shift all that to the left. And then another big part of DevOps is just being very mindful of sharing stuff. Kind of in the good old days, for me, knowing how to do something, like that was mine. I don't want to tell anybody how to do that. I'm the guy for that. Everybody comes to me to do that. That's not how DevOps works. We actually want to share the information. If you've read the Phoenix Problem or Phoenix book, gosh, I can't even talk, Phoenix Project, you probably remember the character in there. I think his name's Brent. But he was that one person, that single point of failure that everybody had to go to solve the problems. We got to get away from that. We got to transfer knowledge and be able to share all kinds of information of what's going on with the applications and the infrastructure and just all day-to-day operations. And then that helps this empathy piece. Empathy is something that comes up a lot in DevOps. If you can start sharing the pain, then people start, just working a little bit different. They start reacting different. They start helping out in different ways. So those are all important, but I would say that the most important thing really for this talk and any talk that you hear at DevOps Days or really any sort of modern IT conference, the most important thing you can do is just constantly and continuously improve. Every single day you should be looking for something new that you can improve. You've got a script that runs, it saves the day, but it takes 10 minutes. Can we make that 5? You got people that are on call. They get paged. It takes them about 2 minutes to acknowledge. Can you cut that in half? There's all kinds of different ways that you can continuously improve really everything that you do with software and the infrastructure and in our day-to-day jobs. So don't take it for granted that this is the way we've done it, this is the way I do it, and I think I've pretty much figured out the best way. There's always another way. There's always something that you can do to make things better. So with that, I thank you very much. My name, again, Jason Hand. Follow me on Twitter, and I appreciate you hanging out.
So we have time for some questions for Jason, just a couple. So anybody have questions? No questions.
Oh. There's one down here.
Great talk, Jason, as always. And you mentioned a controversial and I think important point I would like to have you expand on a little bit.
Sure.
This idea of putting developers on call. Even if the people who can make that decision are on board with it, logistically speaking, how do you suggest getting started doing that?
Yeah, it's a great question, and like I said, it is a very controversial thing. I know plenty of developers who, they went to school, they got trained, they love developing and just writing code, but taking care of it once it's in production, that's just not part of their bag. They don't. In fact, at VictorOps, we've lost some developers because they didn't subscribe to that idea. So the advice that I usually have in that situation is, first of all, you should never just throw a developer under the bus and just give them an on-call rotation. There should be a primary and a secondary, and the other person with them should know a little bit more about the infrastructure, about the operations of the system, and so that they don't feel like they're just doing this by themselves. If you give them the pager on a Friday and say, good luck with that, it's probably not going to go over well. But if they know that they're going to be on call, yet they've got backup, they've got somebody else who they can ping and chat with and collaborate with, that's going to be a much easier pill to swallow. I would also say that you don't have to necessarily put developers on call all the time. Depending on the size of your company, you may be on call like once a month or once a quarter or once a year. And that's really not that bad either. So I think there's several ways you can sort of ease them into this situation. You're not just expecting them to just do exactly what long-term sysadmins have been doing. But it's a matter of just really easing it into it and making them feel comfortable that they're not on an island and they're not all alone. Any other questions? Yeah.
Hello.
Hey.
I'm just a little bit curious about the metrics that you've given. The number of changes per year, does that include just simply the releases, the full releases, or every single small change that goes through the change approval board?
Yeah. So I think it's up to you, but I believe for that report, they're talking about every change that goes into production. So it may not be a major release, but anytime that they're pushing through the pipeline and it gets out to the users, I think that's the changes that they're referring to.
I see. And the other strange thing to me was you gave the numbers for the failure after the change, and the numbers you gave were like 10 to 30%.
Right.
And that looks quite high to me for production changes.
Yeah, kind of scary to think that that's the rate of failure. I think you have to keep in mind that when we talk about failure, we talk about incidents, it can range in lots of ways. So maybe something did make it out in production, but we've just discovered that it didn't take out the whole system, but there is some sort of problem that now we're detecting. The API is not providing 200s back or whatever the case is. So there's lots of different types of, things that you could attribute to a failure. So I think, again, it depends on how you want to identify that failure. I think for the report, I think my assumptions is that if it caused any sort of unplanned outage, unplanned disruption in service, that's what they're calling that. And so 0 to, I think it was 15%. I think that right there, that metric just sort of helps illustrate that failure is going to happen. I mean, in a system, the basic property of a system is that it changes. That's how you define a system, is that it's always in motion. And so with those changes is going to come failure. And that's why we try to avoid language like root cause, because there's so much in motion, it's really hard to identify a single thing, but things are going to fail. There's always going to be change. Does that answer?
All right, we're going to wrap it up there with questions. Thanks again, Jason.
All right, thank you.